So as I mentioned, and as Caroline teed us up for, we'll be speaking about AI governance in a slightly different set of perspectives. My name is Jordan Jasuda Fisher. I am a lead AI developer and solutions architect at IBM's Federal Consulting practice. With me today is my colleague, Gretchen.
Hi everyone, my name is Gretchen Forbush and I work with Jordan within Federal Consulting. I'm an AI developer on our team.
Thanks. Yes, I can speak louder, and I can bring the mic with me so that you hear me very loudly. Hopefully we don't have any cord-related mishaps, but I can't promise anything. Okay, so I'm Jordan Jasuda Fisher. I work in IBM's Federal Consulting practice. This is my colleague Gretchen. We're going to talk about AI governance, to recap. So, as Caroline was explaining in her presentation just prior, we have, AI governance has many facets. Caroline spoke in particular to some of the organizational aspects of AI governance, in particular regulatory compliance. Gretchen and I are going to speak more about the lifecycle governance and risk management elements. So we're going to get a little into some technical weeds when we talk about lifecycle performance. So before we get too far into that, I just want to ground us in universal definitions so that we make sure we're all talking about the same thing when we say some concepts. So I know we all know what AI is in a grand concept, right? We're at the GovAI Summit. But to clarify, AI is a very large umbrella category that basically just means something that used to need to be done by a human and can now be done by a machine. That's AI. So as you can imagine, this includes a lot of very old and uninteresting technology, right? When we talk about the more exciting advances in AI that are revolutionizing the way we all work in recent years, we are talking about a subset of a subset of a subset of this overarching umbrella category of AI, wherein, as we move down this sliding scale of subsets, we are giving the machine more and more autonomy at each step. So the most recent, most autonomous machines are foundation models. In foundation models, we allow the machine to draw its own conclusions when we train a model, it makes its own conclusions based on the data we give it. So it is recognizing patterns in data without being told what the truth is and without being told what kind of conclusions it should draw. This takes a lot of work hour burden off of the humans training the models. But as you can imagine, it also comes with additional risks, which I think we all are at least somewhat aware of. But it also gives us really strong models that can do a lot of different things. And one of those things, probably the most famous, is it can generate new content, which is generative AI. I'm sure we've all heard about it. So we'll talk about that a little bit later. But now that we have our universally understood definitions, let's talk about AI governance. So as I mentioned, Caroline spoke a lot to the more organizational side of AI governance, and we're going to get into some of the more automated AI governance for lifecycle governance when we are automatically capturing metrics and performance data around our models and monitoring that and making sure our models are doing what we want them to be doing. So that can look like a number of different things. We want to make sure that our models are performing the way we want them to perform over time, right? That includes monitoring and addressing any drift in the model performance or the data that the model is running on. We want to be responsive to changes in the needs of our users. That could be because of a change in regulatory environment. It could be a change in the organizational mission. We want to make sure that our models are keeping up with these things and are not just stagnant at a point in time, right? We also want to make sure to manage our risks. Very standard practice for risk management is separating regulation by the risk involved in each use case. So referring back to the EU AI Act, which is sort of a something of a best practices standard in the regulatory space for AI right now. It famously categorizes use cases into different levels of risk and then regulates higher risk models more strictly than lower risk models, right? If we have a model that's making decisions on healthcare, we want a lot of regulation and we want to make sure that that model isn't making any bad decisions because it could be the difference between life and death, right? On the other hand, if it's a model that's like making a silly poem, it really doesn't matter if it does a bad poem, right? So we have different levels of risk for different use cases, and we want to regulate according to that and manage the risk according to that. And even though I'm mentioning a legal framework which applies in some countries but not others, that's still a very recognized best practice even when we are not legally obliged to follow it. We also want to make sure that our models are auditable. This includes transparency into the decision-making that happens inside of the model, insight into the data that the model is trained on, right? We don't want to just assume that the training data is fine and then find out later that there's some really harmful content in the data that the model was trained on. And we want to make sure that we have some degree of traceability of the records as they move through the model. A lot of this can be addressed, or at least can begin to be addressed, as we begin to design our model. Before the model is running, we want to make the design such that it is planning ahead to make sure that we can address all these things in our model once it goes to production. So that includes safeguards. Sometimes systemic safeguards can address potential risk in the result of the model itself. We want to make sure that all the data that we're using, both for training and for testing, is going to be thoughtfully and responsibly selected, right? And we want to make sure we're governing that data as well. And a lot of this can be achieved as well in collaboration with the people who are using the model, who are the subject matter experts of this use case, because they'll be most familiar with those risks and pitfalls potentially. So we've talked about AI governance conceptually. We've talked about Gen AI and how it fits into the overarching AI framework. But when we talk about AI governance for Gen AI, there are some special considerations that we want to take into account. I want to just touch on one technical concept. Forgive me, it'll be quick. But which will help us understand the rest of the conversation about this. Pardon. So, word embeddings is an important technical concept for natural language models, which is not new to foundation models, but it is fundamental to them. So this word embeddings is just a concept. It's a way of treating regular human language words. Each word represents a concept, right? And each concept has dimensions. In these simplistic examples, we have, a cat is alive, a house is not alive. So these are dimensions of each of these concepts. And when we embed these words, we are assigning them numerical values to each of these dimensions. What this does is it allows a computer to understand the language that we as humans inherently are processing without thinking about it, right? So this is key for a lot of things. You can for a lot of computational understanding. So you can see that like cat and kitten are really related concepts, even though the words don't look the same, right? Or at least not very much the same. So it allows us to identify synonyms or some conceptually similar words. It allows us to draw parallels like gender differentiated terms and things like that. And it's, as I say, it's fundamental to the more advanced linguistic AI models. So when we have, it was going to be quick. When we talk about AI governance for generative AI, we have challenges that we're not facing with traditional machine learning, in large part because of linguistic foundation models' advanced handling of synonyms and understanding of context. When we generate new content with these large language models, linguistic foundational models, we can get variations and inconsistencies in the linguistic choices in the output that nonetheless mean the same thing, right? So to make like a very simple example, maybe we need the model to output something about cooking, but instead of cooking, it says baking. Like, is there probably a technical difference between cooking and baking? Yes, but it may, in a context, effectively mean the same thing, right? So in cases like that, we want to make sure that our assessment of a model's performance takes into account those gentle linguistic differences, right? So that is a big challenge for assessing accuracy in AI, in generative AI models. But then we also, because we're generating new text, we have to assess also the model's linguistic choices, right? We want it to be coherent English or whatever language we're generating output in, right? We want it to be to sound like normal speech. We want to make sure we want to make sure our model isn't choosing words that could connotate bias, right? Of course we want to make sure to avoid hate speech or toxicity in our responses. So when we look at these challenges, we have several approaches we can use. Gretchen is going to get into the application of these approaches a little later. But we have, if we go to look at accuracy, if we take a more traditional approach, we would be looking at a token level comparison, comparing words, right? Did the word cooking appear? But if we take that traditional approach, which can work for some cases if the question is like, what's the address to the White House? There's only one address to the White House. It should say 1600 Pennsylvania Avenue. It's cool that I know that. It should say that it should have 1600. If it doesn't have 1600, it's wrong, right? So in some cases, this token level comparison may be important. But for a lot of use cases with generative AI, we really want to assess the semantic similarity, the conceptual similarity of the tested answer, the answer that we're testing, versus the answer that we consider true. So in the smaller text in the parentheses, we have several methods for that, which again, Gretchen will demonstrate in application later. And then for linguistic choices, we have GEval, QAG for fluency, tests for toxicity, that's hate, abuse, and profanity. And then for bias, we want to make sure that that we're assessing metrics across protected variables, like protected classes, to ensure that the responses are equitable across different groups of people and users. So I've referenced it several times, but I will now hand things over to Gretchen, and she will show what it's going to look like to put this into action using watsonx.governance.
Thanks, Jordan. So here we have IBM's watsonx Governance. This is part of the suite of tools that IBM has released that is going to be built to help direct, manage, and monitor all of the AI activities within your organization. So there are 3 primary pillars to watsonx Governance. Caroline mentioned one of them in her last presentation where she spoke about regulatory compliance. Regulatory compliance is making sure that you are up to date with the latest and the evolving regulations coming out of your government and your organization. The next 2 we are going to cover in our demo. So that's going to be lifecycle governance, which is going to be monitoring your AI models. They are going to be completely vendor agnostic. So whether your models are coming from IBM or they're coming from AWS, you'll be able to monitor them within watsonx Governance. They can be on premises or on the cloud. So no matter what types of models you're using, where they're going to be stored, you can use them in this tool. And then lastly, we'll talk about risk management. So following these metrics for your models in real time, making sure that once they're deployed and even during your development, you're able to track, are they being biased? Is there any drift that's being exhibited? So here we can move to our demo. So within the watsonx Governance console, thank you.
Bear with us. we go.
Maybe. Awesome. So within the governance console, you can define projects. And in this project here, we'll go to the overview where you can add users that you'd want to collaborate with, people on your team, within your organization. You can add data, you can build foundation models, and then tune them with labeled data from your use case. When we go to assets, we see all of the prompts, notebooks, data that we have incorporated into this project. So I created this specific use case where I went to data.gov. I grabbed data from the Department of Transportation where they were logging any recall information for vehicle parts that were reported to them. And previously, there was this consequence summary that was manually created describing what the consequence of this recall would be and why users should be concerned about it. Instead of creating that manually, what we can do is we can create a prompt where we have a foundation model produce this consequence for us so that a DOT employee won't have to do it themselves and read through all of the recalls. So we'll go to this prompt here, where previously I had typed in this prompt, which asks the model to produce the reason from a given input text. I provided an example, and then we can go up here where we can evaluate how it works on a set of test data. So first, we'll go through and decide which dimensions we want to evaluate our models on. Because we're using a specific content generation task, it'll provide us with some suggested generative AI quality metrics. So those metrics that Jordan mentioned here, and they're defined in the description column, so you can toggle this on or off if you care about these. We would hope you do if you're using this console. But then all generative AI models are also monitored for model health. So that's what is the throughput, the latency of your model, so more of what is the efficiency rather than how is the model itself performing in terms of like governance for performance. So then in the next tab, we can select the test data that we want to evaluate the model on. I have this truncated recalls data that will hopefully load faster than the entire set of data. And it automatically populates based on the CSV that I provided. There's a recall description and then a column for the consequence summary. And finally, we just say, yes, we want to evaluate this. And so depending on your type of prompt, the complexity of the prompt, the complexity of your data, how much data there is, the time it takes to load will depend. Hopefully this will take a few minutes. But once we get to then the evaluation dashboard, it will show us those metrics that I defined before. So all of the dimensions that we selected. And we will see that it ran a test and evaluated it on the built-in metric standards for each of the metrics that we defined before. And based on those threshold levels, this test failed. So we'll be able to see why that failed, what the output metrics were. When we go to see how our model health is performing, this is just those high-level latency, throughput, and so you can also toggle within a set of time. So if this model is in production, is it going to be, do you only care about like the last month? How was your model performing? Or the last day or last few minutes? How can you isolate the time to when something may have gone wrong within your production environment? But here, we care a lot about the generative AI quality. And that would be like the text quality, blue score. It seems that the data that we provided, the model isn't performing well on many of the metrics, likely because the prompt needs to be tuned more. And so you can evaluate your model based on this dashboard here. Then one of the most important things about governance is being able to distribute this information to any stakeholders. So maybe not just your development team, but the leadership within your organization. And that's what the AI fact sheet does, is it collects all this information, the metadata about the model, plus all the metrics that we just showed in a single fact sheet. and that can be exported here at the top to a PDF, HTML, so that you can distribute it. Here, Caroline previously talked about use cases. So anytime your organization wants to be using a specific AI model, you have a reason to be using AI, you can associate each of your models with a use case. And that way you can be tracking where it falls within the life cycle of model development. And that will be shown on this fact sheet as well. So it shows what foundation model we're using. It describes the prompt with my name everywhere, and different parameters that were used. So not just what the prompt is, but what were the hyperparameters that we used on the model, so that maybe we can tune those later down the line to improve it. And then here we see our results. So you see here on the side, there are multiple test results, and that's because throughout the day I was testing this, and each test run will have a different test result stored within this fact sheet. So it's easy to trace over time. And then we will scroll down to additional details where you can add specific metrics that maybe aren't automatically included for your model, and add attachments. Say your client or your organization wants to be adding information like background details about where this prompt came from or where the data came from. You can add files here, whether it be through this console directly, through a Python software development kit, however you're building this fact sheet. And last thing I wanted to note was that we mentioned that there are these thresholds here, which are how the models are evaluated. And these thresholds can be tuned to your organization. So similar to the question that was asked in the last presentation, say your regulations are based off of different standards than what the government is asking for. You can tune that so that you won't be getting this red flag if, say, you're a little more flexible, or if you want to be more strict about your metrics, then you will be able to reflect that within the fact sheet. So that is all that we have for today. We're open to any questions, and thank you all for attending.
Say that one more time, a little louder.
No, so this watsonx governance can be used for any model, whether it be existing. It can be from any source. So we're actually deploying it within our organization and using it for models that have existed for years now. But you can also create models within watsonx AI and start from scratch. It may be more complicated depending on your use case to do either. So it depends on what kind of lift you're willing to take. Yeah, that's a great question. So it depends for this case specifically. So because we're using a generative AI model, we don't necessarily have, do you mean like training data? Yeah, so for a use case that I have used, it will have information about the training data, about different categories within your data. You can also add that by adding the attachments. So it's really customizable to your use case. Mm-hmm. Mm-hmm. Yeah, that's a great question too. So this, sorry, no, that's okay. I'll see if I can pull it up again. But so that one test was basically, did it pass all of the metrics or no? All of the thresholds. And you can change that depending on what your organization needs it for. So the test you can have multiple tests, you can add tests, change tests. Yeah, so it's going to be the same prompt the whole time, but all of the tests are going to be evaluating how that prompt performs on different kinds of data and all of the different metrics.
Yeah, so you remember me talking about how there are a bunch of different like complex factors that we want to make sure we address when testing. Yeah, so maybe It's super accurate, technically speaking, but it's using language that is like, you don't want it using that language. So it would fail the bias test, and then it would give you overarchingly, no, this test failed. And then you would click into it and see which test failed. Oh, the bias test failed? Okay, let me look at this data. Oh, yeah, those aren't good words, you know? So depending on each case, a different test may fail or you know, not meet the threshold, the standard that we've set for it. It could be bias. It could be, you know, like fluency. It could be maybe something's gone wrong and we are not answering accurate information about a set of regulations that, you know, it's a RAG use case and we're trying to answer questions about regulations and it's like not doing that well, then we would need to go back in to look at what's going on with their model. Maybe it's the context window, maybe it's, you know, who knows. Could be any number of problems, but we would be able to narrow in on what we needed to look at. Did you have a question?
Person or the mark or the thing that's deciding which language is okay and this is not okay. You know what I mean? And then when it does it, is there certain use cases where it is okay here, but not okay there? You know what I mean? Especially when it comes to like talking slang or cultural references and things like that.
Yeah, so there is a good amount of human involvement when we set up these tests, right? The goal is to set them up using sort of like human judgment as well as subject matter expertise depending on the use of the model, and then be able to run them in an automated fashion for like efficiency going forward. But it is always important to have a human, again, it depends on the use case, right? If it's like making poems, we don't want it to say anything bad, but it won't kill anyone. Whereas if it's like medical decisions, of course. So, but it, you know, we would want to, where necessary, have human, like a final check. But especially when we design the tests, that would be the place where we could initially say, you know, setting the standard.
How do you mitigate the bias in that part?
In the test?
And no, in the human when they're
Oh, it's a great philosophical question, honestly, because pretty much all AI is currently trained on human data, and like humans, we have a problem. We're not good at not being biased, right? So it is, and so I mentioned several slides ago, there's this concept of checking parity across protected classes. So that would be like, if you ask the same question, but you use feminine pronouns instead of masculine pronouns, do you get a different response, right? So it would be a matter of checking, running the same or keep all other factors equal, change one thing in your question that indicates you're talking about a different group of people and you're testing it proactively for biases that you know do exist in the human like population. So it is an ongoing, you know, puzzle that we're constantly improving at. I wouldn't say anything is perfect at it, but it's there are lots of techniques and things that we can apply when we set up that testing system. Yeah, thanks. It's a great question. It gets us into a lot of like, how can we, you know, but it's good to have these conversations. Yeah.
Just a quick follow-up on that. So for the thresholds you guys have for the different tests, is there like a default value that you would recommend for different use cases, or is everything like individual testing?
I mean, I wouldn't feel comfortable telling you what thresholds to set on your models just like off, you know. There isn't, Caroline talked in the previous presentation, it's very use case based. And I also mentioned, you know, setting up these governance structures in collaboration with the use case owners, right? So if I'm working with medical data, like I'm not a doctor, so it would be very important for me to set my standards based on, you know, working with a medical professional, multiple medical professionals, somebody involved in health equity, right? In an ideal world, we would have access to all these resources and we would be able to make those decisions for threshold of what we need based also on the risk level, right? So is it, you know, if we understand the use case, we understand where that threshold is going to be, that after that, we're really facing a problem, and before it, everything's okay, or vice versa. So I'm sorry, it's very case by case. No, I would say it's case by case. Yeah, I wouldn't want to.
within this dashboard, these defaults were preset. So like when you create, it's not just like good luck, like figure it out. They're like there are these based on best practices. Go ahead.
But you should always check your own case first.
So it's a starting point, but it will evolve as you create your use case.
When we talk about
For
what?
Blue Score.
I think you could do that I think you could do that currently. We don't have to imagine a future, right? Depending on the tests you set up, you know, you could have two models which are identical except they're using different embedding systems and run the same exact identical tests on them, and there you have your assessment of which embeddings would be better. I think it's not hard to imagine enacting. Are you aware of any preset?
No.
I think you could create one, but I don't think we have a preset one. Yeah. Yeah. Yeah, absolutely. And you may have seen in Caroline's presentation before, there's an assessment option by compliance, like metric. I also will plug that IBM has a booth in the sort of expo hall that you can go to if you want to get into more specific details around like what does this graph do? What happens if I click here? And our SMEs can take you through that as well. Yeah, absolutely.